Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So in this video, we're going to write this familiar equation, that the energy of a photon is equal to hc over lambda, where h is Planck's constant, c is the speed of light, and lambda is the wavelength of the photon, in a slightly different way. So often you'll see h equals 6.626 times 10 to the minus 34 meters squared kilograms per second. But another way of writing it is that it's equal to 4.1357 times 10 to the minus 15th electron volts seconds. So this way, both of these ways of writing it are in the front of the book, and they're totally equivalent. But we can also write this in terms of nanometers rather than in terms of meters. So C is equal to 3 times 10 to the 8th meters per second. But since in every meter is equal to 10 to the 9th nanometers, we can also write this that C is equal to 3 times 10 to the 8th times 10 to the 9th nanometers per second. So these two things are totally equivalent. So now with that in mind, if we rewrite our formula, E is equal to 4.1357 times 10 to the minus 15th electron volts seconds, and then times C written in our second way, 3 times 10 to the 8th times 10 to the 9th nanometers per second. We can also, instead of having to convert the wavelength to meters like we usually do, we can just leave it in terms of nanometers. So lambda is lambda nanometers. So we can see that seconds will cancel, and also these nanometers will cancel. And what we're left with is just electron volts, which is a measure of energy. So the dimensional analysis is good here. So if we multiply these numbers together, what we end up with is that E is equal to 1.240 times 10 to the third electron volts times nanometers over lambda, where we measure it in nanometers. So if you're told that lambda is 480 nanometers, don't write that as 480 times 10 to the minus 9th meters. Just write 480 right here. So once again, we can see we're just going to end up with electron volts. So this is a good measure of energy.